Hiya, it's Mr. Baker here with another physics video, and today we're going to be looking at specific heat capacity. So we're going to be looking at specific heat capacity today, and we're going to be answering this question: why do some things stay hot for ages? So specific heat capacity, let's have a look at what it is. Different materials will lose their heat at different rates depending on a factor called their specific heat capacity. Let's look at the physicsy definition of it. So the specific heat capacity of a material is the amount of energy in joules that is needed to raise the temperature of 1 kilogram of the substance by 1 degree centigrade. And the unit is written in joules per kilogram per degree C. So basically, when you've got an object, you'll be able to heat it up and you'll be able to cool it down. If I've got a certain mass of a certain object, then it will take a certain amount of energy to heat it up to increase its temperature by 1 degree. If I've got a different material, then it will take a different amount of energy to raise its temperature by 1 degree. And that is the heat capacity of the object. Now, if I've got a specific amount of it, if I've got 1 kilogram of it, then that's where the specificness comes from. So heat capacity is the capacity of an object to be able to store the heat, to keep hold of the heat. Capacity is like the volume, isn't it? It's how much stuff of whatever. So specific heat capacity, if we break that down, you've got capacity, which is the volume, you've got heat, which is a certain amount of energy, and you've got specific, which we're talking about a specific mass, a specific amount. So when we're looking at the specific heat capacity, it's the amount of heat energy needed to raise the temperature of an object by 1 degree centigrade, and specific heat capacity is talking about 1 kilogram of that stuff. So if specific heat capacity is the thermal energy required to raise the temperature of a body of mass 1 kilogram by 1 degree centigrade, then we can have an equation here, which is E is the energy, M is the mass, C is the specific heat capacity, and delta theta, so that little triangle is the symbol delta, which means the change in, and theta there is another little symbol which means temperature. So here are the quantities and the units. So E is the thermal energy supplied or lost, because it can be being given out or actually being increasing the energy of the object, because that's energy, that's measured in joules. The mass is measured in kilograms. The specific heat capacity is joules per kilogram per degree centigrade. And then the delta theta is the temperature change of the object. In physics we say the body when we mean the object or the thing. So the temperature change of the object in degrees C. Right, so you'll need to do a little bit of practice using that equation, but that's a little introduction to it. And these are the things that you should be able to do. You should be able to describe materials in terms of being difficult or easy to heat up, increase the temperature of them. You should be able to list the factors that affect the amount of energy required to increase the temperature of an object from the things that are in the equation, and you should be able to use the specific heat capacity equation, so you're going to need to do a little bit of practice to do that. So why do some things stay hot for ages? So if they've got a high specific heat capacity, then that means that they'll be able to keep hold of their heat. If they've got a large mass, so if you've got a large amount of it as well, that will help. So those are the things. And if the change in temperature isn't very high as well, then that might also help. So if you've got an object that is hot in a hot room, it's going to stay hotter than if it was in a cold room as well. But when we're looking at this, really for this lesson, why do some things stay hot for ages? Things that have got a higher specific heat capacity will stay hotter for longer because they've got a higher specific heat capacity. Okay, so that's been all about specific heat capacity. I've been Mr. Baker, and I will see you next time. Thanks very much.